Exercise 11, question 30. Okay. A copper block of mass 2.5 kg is heated in a furnace to a temperature 500 degrees Celsius and then placed on a large ice block. So, did you understand what is given? A copper block is there. Okay. This block is heated in a furnace to a temperature 500 degrees Celsius and then placed on a large ice block. So, after picking it up from the furnace, it is kept on a giant ice block. Okay. Given the temperature of ice, but no problem. The next sentence makes it clear. What is the maximum amount of ice that can melt? Why will the ice melt? Because heat will flow from copper block to ice. Clear? Sure? And you know that until all the ice melts, the temperature will not increase beyond 0. It could be minus 10. It could be minus 10. Correct? Possible, right? Minus 10 my eyes are open. But then why am I saying that it's going to be 0? Because the question says what's the maximum amount of ice that can melt. See, if you want maximum amount of ice to melt, you will realize that suppose this was minus 10 degrees, then maximum amount of ice won't melt. Why? Because some heat will go to increase the temperature, some heat will be used up to increase the temperature from minus 10 to 0. So for getting maximum melting of ice, it is necessary that all the heat available goes to only melting the ice, not in increasing its temperature. So for getting maximum melting of the ice block, we should have the temperature of the ice block as 0 degrees Celsius. One more. The heat loss the highest then. Again, we are trying to calculate the maximum amount of ice that melts. So it means we will ignore or we will neglect all the heat loss. Because more heat loss means less amount of ice will melt. Got it? Okay? So maximum amount of ice to melt, right? So for that it is necessary that this copper block, okay, which is releasing heat, will go from 500 degrees Celsius to what? Up to what time will it release heat, or up to what condition will it release heat? This is supposed to give heat to ice. So up to what temperature can it give heat to ice block? 0. Understood? Yes or no? No, not clear. This temperature cannot go below 0. Why? Because this is hot and ice is cold, so it's going to release heat to ice and ice will melt. 0 ke niche to no jai ne. You understand why? At least, it's impossible. Yes, heat does not go back and forth in that way. Understood? So this cannot go below 0. If you take this is 0, then this cannot go below 0. Understood? Absolutely clear? So this is what happens with copper. On the other hand, what will happen with ice? Ice will just melt, right? And it will make water out of it. But the question is how much, right? This is the question. What is the maximum amount of ice that can melt? So we have to find how much is the mass that can melt. So this will release heat and that will absorb heat. Let's start writing the term. Again, Q equal to 0. Why am I writing Q equal to 0? Again, heat loss should be 0. If there is no loss, only then the maximum amount of ice will melt. Baki to heat jati rehte. Okay, so Q is 0. Therefore, Q for first process, like you could call this 1 and you could call this 2, plus Q2 is equal to 0. Or you can say heat change for copper and heat change for ice is 0 and you. Right. Therefore, what's Q1? First process. Is it what? Change of state or change of temperature? Change of temperature. Clear? So, mass. What is the mass of copper? 2.5. M S S. Special heat of copper. बराबर ने copper specific heat of copper what is the specific heat 0.39 joule per gram this is 2.5 kg so 0.39 into 10 raised to 3 converted the gram to kg per kg okay at least 10 raised to 3 then delta t what is delta t q equal to delta t minus 500 isn't it okay or not okay plus q2 second process this one is actually which process melting of ice that is change of phase or change of state so q equal to ml understood everyone got that ml what should I have m do we know the mass m we have to find how much amount of ice will melt so we have to find the mass that melts clear or not clear suppose m kg ice melt no that's what we are saying okay suppose m kg ice melt so then that's going to be m into l by l lp or lf latent heat of fusion આવશે ને melting that is fusion understood is equal to 0 put the value in there find out what is m heat of fusion of water 335 joule per gram don't forget to convert it to kg right joule per kg કરવું પડશે ને hurry up come on એવું બધું તો અમારે done unit લખી નાખજો બરાબર kg kg આવશે so what are the you will get 1.45 okay fine let's go to 14th question okay now we're solving exercise question 14 what does it say in an experiment on specific heat of a metal 0.2 kg block of the metal at 150 degrees Celsius. So there is a 0.2 kg block at what temperature? 150 degrees Celsius. Okay, so there is metal at this temperature. Is dropped in a copper calorimeter. Okay, dropped in a copper calorimeter of water equivalent 0.025 kg. Okay, this is a new word. Okay, what is meaning of water equivalent of something, whatever it is, water equivalent. Water equivalent means, this is this level. It means that it's going to behave, listen, it's going to behave as if it's that much water. So for example, here it says, is dropped in a copper calorimeter of water equivalent 0.025 kg. So what that means is that this copper calorimeter, its vessel and all the covering, everything, that behaves as if what? It is 0.025 kg of water. Say copper, don't forget. But it is that much copper which would behave similarly as 0.025 kg of. Did you understand what this means? Because when it comes to absorbing heat and releasing heat, okay, water and copper are different. So we don't know the mass of copper, no problem, we don't need to know. All we need to know is that this copper calorimeter can be thought to be this much of water. It behaves in the same way as far as absorbing or releasing heat is concerned. Okay. Now, what's given? Containing how much water? Now this calorimeter, okay, calorimeter behaves like this, alright, but there is also some more water. How much water is there? How much water is there? 150 centimeter cube. But 150 centimeter cube means 150 gram of water. I'm sure you know that density of water in CGS unit is 1 gram per centimeter, right? So 150 gram of water. So do you realize there is total how many gram of water? 150 gram actual water. And the calorimeters copper behaves as if it is 25 gram of water. So total amount of water can be thought to be 175. If you understood that 175, then I'm sure this sentence is clear. Say copper, but behaves like 25 gram of water. Got it? Okay. Then what's the final temperature? Final temperature 40 degrees. Oh, so this is what we know. So this is temperature, final temperature of everything, right? 40 degrees Celsius is the final temperature of everything. Water's initial temperature. So water's initial temperature is 27 degrees. Okay, water's initial temperature is 27 degrees. Compute. Compute means calculate what? The specific heat of metal. Right? Pachi આગળ વાત. Right? Let's do this. Come on. So કરવાનું ચાર્ટ બનાવવાનું ને. Right? What is getting hotter, what is getting cooler? That's what you have to make a chart for. Ascending number 14. Made up everyone. One side is releasing heat, one side is absorbing heat. So first of all, metal. At what temperature? 150. It will cool down, isn't it? When you drop it in the calorimeter, it will cool down. To what temperature? 40 degrees Celsius. So this will be metal once again at 40 degrees. Let's say, what's the other party? Water. See, when we say water now, it will mean this water and also the water equivalent. So we can just say water, which includes everything. So what was its initial temperature? 27. From that the temperature increases to 40. Again, this water includes everything. Okay, that's right. Including calorimeter. Including calorimeter. Okay. That's it. There was there. So Q equal to 0 for isolation. So we should have Q1 plus Q2 equal to 0. So this is number 1, this is number 2. Number 1 process is what? Change of state, change of phase. Change of temperature. Excuse me. I said it. Change of temperature, not state. So what should we write? M S delta T. What is M? Mass of metal. So how much is it? 0.2 kg. Okay. S of metal we have to find. I'm just writing SM over there. Delta T. How much is delta T? Minus 110. Isn't it? Okay. Q2. What do you think Q2 will be? Change in Q will be MS delta T. So what's the mass? 0.175. Why is it 175 gram again? 150 gram of actual water and 25 gram of calorimeter equivalent. Okay, so 175 gram or 0.17 into S of water. What is S of water? 4.186 into 10 raised to 3 in SI unit. Joule per kilogram to Kelvin. And into delta T. What's delta T? 1330. And that is equal to 0. So now it is solved. બધા ક્વેશ્ચન એક જેવા જ નથી. Okay, I'm erasing what I've written on the left side here, sorry, the right side here. Thank you. Done? Yes. Now, let's go over to the next question. That's what it says. If heat losses, we have something further. If heat losses to the surroundings are not negligible, you understand what it means? Generally, we consider that it's all isolated, but in reality, it means not. They are saying that if the heat losses are not negligible, is your answer, is the answer that we have found here, is it greater or smaller than the actual value for specific heat of metal? What do you think? Either answer smaller or greater? Smaller value minus. So it's saying that what would be the correct value of Sm, right? That's what we have to compare. See, if there would be some loss, okay, then what that means is some of the heat would be going away as what? Escape. It would escape from the system, isn't it? So there will be some loss of it. આની પાસે જે energy હતી, this metal top, it had energy. Okay, it would be losing some energy over there, correct or not? So actual energy content that it had would be more. સમજાણો ને? So that means the correct value, true value of Sm, the true value of Sm will actually be larger than what we have calculated. समझ पड़े છે? The true value of Sm will be large. Got it or not? It's saying that suppose this calculation we did, we assume 0, correct or not? પણ એમાં actual loss થઈ ગયો હોય તો, that's what they are saying. If there was a loss, then our calculated value will actually be smaller than the true value. That is, true value will be larger than our calculated. So I'm saying that true value of specific heat of metal would actually be greater than the calculated value. That is our answer. This answer is nothing but the answer that we have got. So for example, what's the answer we have got? 0.433 10 raised to 3 joule per kg Kelvin. The actual value આનાથી વધારે. You understand why? Because some of the heat would have been lost. Okay? Right. So now let's go to question 18. Question 18. તેને તમારી બુકમાં 18 કે નથી? The question આ છે ને, a child is running a temperature. Okay. What is the total number of questions in your book? 21. 22. My 22. But the order would not be same. Never mind, we are solving this question. Find it from your book. A child running a temperature of 101 degree Fahrenheit. Okay? Right? So, let's read that. We are solving this question, which could be number 16 or 18 in your book. I can't say which one. Okay, exercise 11.16 or 18 depending on what you have. Okay, weird times these. So it's about a child. Okay, and child with lot of fever. So a child running a temperature of 101 degree Fahrenheit. So what's the temperature of child? It will be 101 degree. Is given an antipyrine. Antipyrine is a medicine that tries to reduce the fever. Anti means opposite, and pyrine, pyre means to fire or be hot. Okay, so antipyrine, which causes an increase in the rate of evaporation of sweat. What does it do? It increases the rate of evaporation of sweat. And you know that sweat, which is mostly water, when liquid will evaporate, it will absorb energy from our body. So that's why our body will cool down. Understood how it works? So it says that this antibiotic, which causes an increase in the rate of evaporation of sweat from the body. If the fever is brought down to 98 degree Fahrenheit in 20 minutes, how much time did it take? It takes 20 minutes to go from 101 to 98. What is the average rate of extra evaporation caused by the drop? Okay, what is the average rate of extra evaporation? Why extra evaporation? Even at 101 degree Fahrenheit, the child's sweat would be evaporated. But because of extra evaporation, the temperature decreased by 3 degree Fahrenheit in a time of 20 minutes. So what is the average rate of extra evaporation? Average rate of extra evaporation means mass per unit time. Does that make sense? Sweat will evaporate. How will you measure sweat? Either in mass or in volume. You understand what I am saying? Mass is a better option. So we are finding per unit time how much mass of sweat is getting evaporated. Extra. Normal માં તો 101 આવે બરોબર. But how much extra is evaporating when the temperature is changing from 101 to 90? Understood? Find करવાનું. How much extra mass of water or sweat is evaporated per unit time? The mass of child is 30 kg. Okay, the mass of child is 30 kg, and the specific heat of human body. Let me clarify here. I am writing MS. MS for mass of sweat. Okay, and mass of child is given to be 30 kg. Right? The specific heat of human body is approximately same as that of water. The specific heat of child, okay, is same as specific heat of water. Right? Why so? Because you know human body has a lot of water, nearly 70% is water. And the latent heat of evaporation at that temperature, latent heat of evaporation, so like LV, what is that? 580 calorie per gram. Okay, 580 calorie per gram. We don't like calories. 580 into 4.186 into 10 raised to 3 joule per kg. Okay, understood what I have done? 1 calorie is how many joule? 4.186. And then this is in gram, we converted it into kg. Give the SW 4.186 into 10 raised to 3 joule per kg. LV. Okay, so this is what we have. ms by t find करवाना है, very easy, right? So to decrease here, think of making a chart like this. Come on, question को मोटो है, on करवाना you doubt नहीं. Think of making a chart whose temperature is increasing and whose temperature is decreasing, or who is releasing it and who is absorbing it. Child is releasing it. Is that okay? Child's body is releasing it. So here is child. Okay. Earlier child was at temperature 101 degree Fahrenheit. Convert per equal. After releasing it, we have one again the same child, not a different child, at 98 degree Fahrenheit. Okay. Atlu છે ને? Right. On the other hand, what's the receiving party? Sweat. The sweat. But sweat is water. Okay, largely sweat is water. And what does water do? Water is at what temperature when water comes out of your body? Get a temperature. It would be same as body temperature. Don't you think? Yes or no? Water would be same as body temperature. Correct? Clear? Absolutely clear? So, this is going to be an estimate. And 101 to 98 change that. Make sense? So, if you want, you can take an average of sorts. 101 and 98 average to that. 99. Okay? Sure, what's that? But our temperature change, do you realize what I'm saying? For example, let's start when the child is sweating, the temperature of sweat will be 101 degrees. Here body turn to that. The sweat cool, that is from at the start when the boy was sweating or the child was sweating, the temperature of sweat was 10. Finally, when the child would be sweating, the temperature of sweat would be 90. Ultimately, from some temperature, it has to evaporate. Does that make sense? So it has to go to water at now तो at same temperature से never mind. तो कहीं कराना नहीं. Gaseous state, vapor. Did you understand what I'm writing? Yes or no? Come on, wait. I'll repeat. It's not boiling here. See the difference. Our water given the temperature for it. It's not supposed to go to 100. Why not? What's the difference between vaporization and boiling? ખબર છે? ગ્લાસમાં પાણી રાખો, પાણી ઉડી જાય કે ન ઉડી જાય? ઉડી જાય. ઉડી જાય ને થોડા ટાઈમ પછી ઉડી જાય. તો એ બોઇલિંગ કહેવાય. ન કહેવાય ને. What is it called? Evaporation or vaporization. Clear? Same temperature versus only what is changing? Temperature is not changing, no problem. What is changing? Phase is changing. Does that make sense? Yeah. But yes, this temperature definitely changes. If the sweat temperature changes, but here it is given to us that we have to take this as the latent heat of evaporation or vaporization. समझाऊँ? Okay. So let's start. We part say 1 and 2. No. Sorry, Q equal to 0. Therefore, Q1 plus Q2 equals 0. Q1 must be MS. And the mass of child. What mass of child? 30 kg. S. Specific heat of child 4.186 into 10 raised to 3. Delta T of child. This is in Fahrenheit. Convert करवानो Celsius में. Kelvin में. Celsius में drop. How many degrees change of Fahrenheit? 3 degrees. 3 degree Fahrenheit. So this is delta TF. I hope you like that. We have to convert this delta TF into delta TC. So what's that relation? Multiplied by 5 divided by 9. Okay or not okay? Multiply by 5 divided by 9. जो लखाયું છે. We don't have to convert temperature. We have to convert temperature difference. ભૂલી ન જાઓ આ બે વચ્ચેનો difference. 3 આવ્યો ને તો આપણે ડેલ્ટા TF ને શેમાં કન્વર્ટ કરવાનું છે ડેલ્ટા TC એ બેનું શું રિલેશન લખાયું છે ને ડેલ્ટા TF અને ડેલ્ટા TC નું રિલેશન ઇટ ઇઝ delta TC equal to 5 by 9 into delta TF. Clear or not clear? We are not converting TF to TC. We are converting delta TF to delta T. Right? Okay, so this is what we get. Temperature decreases, so this is going to be negative. Yeah, fine. That's right. Minus 3 plus Q2. Now what is Q2? Here what is going on? Temperature not changing. It comes at the same temperature. You see that? Become water same temperature. So you just have evaporate. એટલે ખાલી શું લખવાનું M into S. But here this will be mass of sweat that evaporate. Is that okay? Equal to 0. Now if you want to find MS by T, plan is we can find MS and then divide by time. Understood? Or we find MS and then divide by rate of evaporation. Okay, so have you got MS value? So how much sweat is evaporating? 86 ms equal to 86.2 grams. 86.2 grams. If you would have done it in kg, then you get a different answer with power system. Okay? So if this is ms, that is mass of sweat evaporated in these 20 minutes. So extra rate of evaporation. Extra rate or rate of extra evaporation. Is ms divided by t, that is 86.2 gram divided by 20 minutes. Okay, so that is 4.31 gram per. Okay, that's what we are getting here. તમને એક જ ક્વેશ્ચન જો આ બધા કેવા હોય મોટો ક્વેશ્ચન હોય so much to understand in the calculation માં એવું કંઈ નથી એ થાય નાના કરતા લાંબા આપણે કેટલા બધા કહેવા 1 2 3 4 કેટલા બધા સ્ટેપ્સ હતા આપણે right okay now let's the next thing graphic problem. increasing everything here. Okay, so ये okay नहीं? Okay. Graph of Q now T versus Q what PT. Very simple thing. અત્યાર સુધીનું જે છે ને એની સમરી જેવું છે. So let's say that you start heating some solid. Okay, suppose you start heating some solid. And at start there was some temperature. It could be anything really. After the value the applicable, let's say initial temperature was T. Okay, and it is in solid state. So if you start heating Q40, what this means is you are giving more and more heat. As you start heating, the temperature will rise. So this graph will be a straight line. Why is this a straight line? Reason is simple. Q is proportional to delta T. That is how much heat you supply. That should be proportional to the change in temperature. Straight line. But at some point, this solid, okay, it is solid. At some point, this solid will reach its melting point. What I say? So this means this is the melting point. Clear? This is the melting point. What that means is, as it reaches melting point, now the temperature will not increase. So, by example, I will until all the ice melts, the temperature does not increase. So even if you are supplying heat, let's say you start with 0 joule, 10 joule, 20 joule, 30 joule, so the temperature will increase. At some point, you reach here. You are supplying heat, but still the temperature will not increase. Is this clear? Temperature doesn't increase, but you are supplying more heat. That is, till this point, you supply, let's say, 30 joule, for example. Numbers are just for example. And till you are using 60 joule. So, 30 joule से 60 joule even changing 30 joule क्या जल्दी रहेगी? It is not increasing temperature. It is only changing the state. Latent heat. You got that concept? Okay. Numbers की कोई जरूरत नहीं है. Give this example. Now, let's say everything is converted. That is, everything has changed from solid to liquid. Now everything is in liquid state. So now, once again, if you continue heating, the temperature will increase. Here also it's a straight line because once again Q will be proportional to delta. Make sense? A slant schema, L for liquid. Here solid. Liquid. Okay, if you are getting confused, write the whole thing. Solid, liquid. The temperature will increase, and once again a point will come where you will get the boiling point. What's going to happen over there? What is going to happen over there? Yes, all the liquid will have to boil before the temperature rises again. Which happens to horizontal. Got it? Okay, again between these two you have latency. And then once again everything is converted. So in the gaseous phase the temperature will start increasing. Is the graph clear? It's not necessary that these slopes are equal. Again, it is not necessary that these slopes are okay. So let's mark out some points here. This one. This is LF. Okay, this indicates LF. LF, that is latent heat of fusion. Okay or not okay? Because here it is, here fusion is going on, so melting now. Here which process is going on? Melting. Over here boiling is going on. So This gap will help you find out LV. But remember, actually when you use the formula, you are going to get heat of fusion is ml. हम तो एक काम करेंगे mlf मतलब ml. What is the meaning of mlf? Mass into latent heat of fusion. ये तो यहाँ तो है mass into latent heat of wave. Do you understand these two as well? मैं कहते हैं QP ने QF और fusion. Right? So let's say this is point A, B, C, D, E, and F. So, can you tell me that if you find the slope between A and B, what would that indicate? Slope between A and B. If you want to find slope between A and B, then do you realize that slope will be Q upon delta T? Here. Yes or no? Sure? Makes sense? Okay. So this Q upon delta T will be nothing but M into X of what? Of the solid. Got it? Clear or not clear? No. Slope क्या था? Delta by delta. Okay, we never write delta Q. Let me tell you that. Writing delta Q is nonsense. क्या वैसे मला पता है? मतलब Q तो पता है delta Q लो. What's law of thermodynamics क्या दे लोगों के? Delta Q Q लो Q लो ना. तो सारी बात है. Delta Q is rubbish. Nobody समझ में मतलब है. The prime and a Q itself is energy transfer or change of energy. So any अगर value delta लगा लो. Understood? Okay. So this is how you get this. એવી રીતે અહીંયા કરો તો અહીંયા શું આવશે? Specific heat of liquid. Idea આવી ગયો ને? એનો idea આવ્યો. So that's about this graph. આવો graph તમે time નો ही બનાવો. For example, instead of Q, you make a graph of time. That is, as time passes, the temperature will increase. Then you need melting point, so it will start melting. For some time it will melt. Then once again, temperature increases. Then for some time it will boil. Got the whole idea? Okay. So that's about it. Now, next topic, heat transfer. Okay, heat transfer. My favorite from this chapter. How easy. Now, heat transfer means how heat or how energy flows from one point to another. Right? So there are primarily three mechanisms. Like if you remember earlier, I told you that people thought that, many years ago, people thought that heat is a fluid and it just flows like water or oil would flow. But that's not true, of course, because heat is not a substance. It is just energy, like from one to the other. So, three forms of this energy transfer are: number one, conduction, which is primarily in solids. Okay, now conduction is only possible by direct contact. By direct contact. What does that mean? Let's say that this is hot. So until you touch it with your hand, conduction will not begin. Is that clear? दूर सी गरम लागे ये अलग होय. That's what we will come for. But until you touch it, until two solids touch each other, conduction does not begin. So conduction only occurs by direct contact. The second one is convection. Convection. Convection is the primary heat transfer mechanism in fluids. Fluids is to liquids and gases, both. Anything that can go around. Okay, anything that can flow around. Okay, that's the gas or of fluids. Right? So, gas or liquid. In convection, what happens is slightly different. Okay. Let me just finish convection right here because we don't have to study convection in a lot of detail. In convection, the molecules of fluid, either gas or liquid, when they get energy, they themselves go and carry it to the other point. Can I just say delivery personally? Okay, it's like if I tell you that okay, this is 100 rupees, go and give it to this person. So you go personally. Okay, you stand up from your place and you go and give. That is what is called a convection. And the molecules do everything. Let's say you put a little candle flame here, or let's say a gas burner somewhere in this corner of room. Then why does everything in the room become hot? You might have noticed that if you enter the kitchen in your house, it's hot. Much hotter than the other rooms. Why? Because a burner burning somewhere, it is going to release heat. Now, the molecules of air in that portion take that heat and they don't just sit over there. They spread out everywhere in the room. So they personally go and transfer heat. Understood? That is called convection. And obviously, you realize it is not possible in solids. Why? In a solid, if you go from one place to that place, possible as nothing. Understood? So convection is only possible in fluids, right? Liquid or gas, either way, but it must go. Understood? Third one, radiation. Right? So radiation is without contact, of course, or without a medium even. Without a contact or even without a medium. What do I mean? If you heat a rod, then heat will flow in this medium. That is called conduction. If you heat air over here, then air will carry or transfer the heat. That is called convection. So it became a medium, solid and fluid. But radiation does not need medium. Radiation is in form of waves. Is in form of electromagnetic waves. Okay, the heat transfer or energy transfer is in form of electromagnetic waves. What's the simplest example of this? The sun. Okay, right? Inside the sun, listen to this carefully. Inside the sun, convection is going on because sun is made up of gas. Fine. But because of convection, that heat cannot reach Earth because between Earth and sun, there is nothing. There is no medium. There is vacuum. You understand what I am saying? So there the heat transfer is occurring by the radiation. That is, sun will emit waves. Some of those waves will fall on Earth. Or when you stand outside in the sun, some of those waves fall on your body. So heat is transferred from the sun directly to your body. वच्चे कोई ले नहीं. It's a direct mode of transfer. Direct contact, touching. Without that, conduction doesn't work. I'm my journey. Okay, right? There is no need of a medium. Understood this so far? Right? Okay. So these are the three. We are going to study this in detail. We are going to study this in detail. Convection, not in detail. Right? Probably we will study fluids later on. Typically in mechanical engineering, or if you go for higher level physics later on, you might study convection in more detail. And convection is important for mechanical engineers. Right? For example, you want to study flow of heat. Flow of heat. Let's say cooling system or a refrigeration system of a building, or let's say you want to design a refrigerator. So refrigerator has fluid inside, gas vacuum, it has a gas. So how heat flows in the gas and in the pipe, so that everywhere it will cool the refrigerator or the inside of the refrigerator. Right? So these are typical examples of where you need to study about. Okay, so conduction, right? One more example of convection. One more example of convection is wind. You know, sometimes you note that when wind blows, like it's hot, typically in summer, in afternoon. So when wind is blowing, it's actually carrying heat from one place to, and carrying energy from one place to another. So heat transportation by convection, but on a large scale. You understand what I am saying? Okay, let's get on with conduction. Now, when it comes to conduction, it is important to understand a few terms. Number one, heat current. Heat current. In 10th standard, you studied current. That was electric current. What was electric current? Rate of flow of charge in unit time. That is Q by T. Okay, heat current is something similar. It is rate of flow of heat. What that means is heat current H or I. So I love to do. You can write H also, no problem. Okay, heat current H or I can be written as dQ by dt, not Q by T, because that would be average. I hope you understand what I am saying. We write dQ by dt. What does dQ mean here? Small heat transfer. I repeat, dQ means small heat transfer. It does not mean change in heat. Remember, change in heat is nonsense. There is nothing like change in heat. So here this means dQ by dt. When this is differential, you can say, or you can also say that dQ is the infinitesimal heat transfer in infinitesimal time dt. Right? Infinitesimal heat transfer, that is dQ in an infinitesimal time dt. What do you think is the unit? Heat means joule, energy, joule per second, that is joule per second. What unit is that? Watt. Energy per time. So unit is understood, right? We'll continue with this.